Hello everybody. Today we'll be solving or taking a look at Red Nose reports from Advent of Code 2024 for day 2. All right, so we're provided this list of what they call levels. Each a list of levels, and they tell us that either the list of levels can be entirely decreasing or entirely increasing. In addition, the adjacent levels can differ by at least 1 and at most 3. Looking at this example, 7 and 6 have a difference of 1, 6 and 4 have a difference of 2, 4 and 2 have a difference of 1, 2 and 1 have a difference of 4 and 2 have a difference of 2, 2 and 1 have a difference of 1. So since all the levels are decreasing by 1 or 2, we're good to go. Looking at this second example here, 1 increases by 2, 1 increases to 2 by 1, 2 increases to 7 by 5, 7 to 8 by 1, and 9. Since 2 and 7 differ by 5, and we're only allowed a difference of up to between 1 and 3, this is considered unsafe. And that's basically the gist of the problem. There isn't much to consider other than that. So let's try coding it. The test data looks something like this. So each line has an new line character appended to it. In addition, the actual values that we are concerned with are separated by a single space value. So let's keep that in mind as we try to convert that input to something we can work with. So we'll do with open So as I mentioned, each line has a new line character appended to it, so we need to strip it. So we'll use write strip, and let's strip that new line. And then we need to split that string into individual numbers that we're concerned with. So we'll use dot split, and we'll split on the space. Now what we'll have is a list of strings. We want to convert those strings to their integer equivalents. So what we'll do is we'll say for I in that, convert it to an integer, and then we'll append this to nums. So let's have a look. So it looks good. Now, what we need to do is check if all of the elements are increasing or all of the elements are decreasing. And the difference between each element can be between 1 and 3. So let's make 2 methods. Define check increasing, and we'll pass the list to it. And what we'll do is we'll compare element by element. So we'll get the length of L, and then we'll say for I in range 1 to n, and we'll compare the adjacent elements and make sure that their difference is either 1, 2, or 3. So if L of I minus L of I minus 1, and because we're using I minus 1, notice how I had to start with the first value of 1. If this was 0, then it would mess up our calculation. So normally we'd want our differences to be within 1, 2, or 3. And I'm using this approach instead of the less than or equal just because I find it a little bit cleaner. What we want to do is check where this fails. And where it fails, we'll return false. But what we will also return is the index where it fails. For this problem, it's not important where the index fails, but for the second problem, it will be. So I'm just thinking ahead. Now, if we loop through all of these values and there is no error, that means this list is good to go. And we'll return none for the index. Now I'm going to make a second function, and I know I can combine them, but I think it's a little bit more visible if I do it like this. So now this is the decreasing function, and now if we check, the values would be either -1, -2, or -3. We would go down, for example, from 7 to 5 to 2. If we subtract, as here, 5 minus 7 is -2, 2 minus 5 is -3. So this is what we're aiming for. Okay. And now what we'll do is, for each list in nums, for L and nums, we'll perform a check. So increasing equals check increasing L. Now notice I have this underscore here, because as I mentioned earlier, for this problem it's unnecessary. And in Python there's a custom to name unused variables with an underscore. Now if one of these is true, we update our total. Okay, let's check it. Okay, and let's verify that. So for our first test, 2 was the expected answer. So we're doing well. Let's continue on. For this next part 2, they allow what's called a single toleration. Going back to our first example here, we don't need a toleration, because each of these is okay without the toleration. Now let's look at this problem here, or this example. So 1 to 2 is 1. That's perfectly fine. 2 to 7 is 5. So that's not going to work, because remember, we're only allowed an increase of between 1 and 3. Suppose we remove this bad value, but now if we compare 2 and 8, that's an increase of 6, which is also bad. So at this point we have at least two violations. So this is not going to work, even with the allowance of a single bad removal. Let's look at this example here. 1 to 3 is 2, which is perfectly fine. But that indicates that this list will be an increasing list. When we look at 3 to 2, that throws a wrench in our understanding, or what our assumption, that this list would be increasing. So let's remove 3. Sorry. Let's remove, yes, sorry. 1 to 3 is okay. 3 to 2 fails. So it looks like we could have removed 2 or 3 and we would have been fine. They decided to remove 3. If we had removed 2, 1 to 3 is okay. 3 to 4 is okay, and 4 to 5 is okay. So in this problem, they decided to remove 3 and it made it okay. So with one removal, with one toleration, that made this list of levels safe. So that's what we'll be doing here. For this problem, we'll try removing 1 and verify if that makes the level safe. If it doesn't, that's considered unsafe. So let's get into it. So I'm going to add 2 new methods. I'm going to call it check increase, and I'm going to call it violation. Violate. And we're still passing the list. And now what we'll do is we'll still run it as normal. So we still want to check if this list is okay without even needing a removal or a toleration. So if OK1, then return true. So we know that it's not safe as it is. So let's try removing the bad index. So let's do OK2, and we don't need it, equals check increasing. So now let's go over how to adjust our list to accommodate this. So what I'm going to do here is go over two examples. 1, 4, 1, 4, 15, 6, and 8. So looking at this problem, 1 to 4 is okay. 4 to 15 fails. That means this would fail. This fails at I equals 0, 1, 2, 2. If we remove this where it fails at, then this would be okay. Now let me give you another example. Suppose we have 8, 1, 3, 5. Now if we were looking at examining this example here, this fails at 0, 1. So fails at I equals 1. Now if we remove this I value, this would still fail. So what we'll need to do is, if we had considered removing the previous right before where I fails, what if we remove this value instead? Then this would be fine. So we'll need to keep that in mind as we perform our secondary checks. So either remove the value at I or remove the previous value. So let's do that. So let's remove I at this point. L of I plus 1. So this would be essentially removing the element at index I. Now in this case, remember we were supposed to remove the value before I, and maybe that was going to help us out. So let's do that. So L to I minus 1. And now let's continue on afterwards. So L of I. Okay. Now if either of these is true, so I think we can just do this here. Return OK 2 or OK 3. Okay, there we go. So if they both fail, even with the removals of either of those, then that means it's not going to work. Even with the one toleration, this would still fail. And let's do the same thing for decreasing. Now again, I know I could have consolidated some of these methods into one, but I think it's a little bit clearer if I do it like this. Okay, so let's try that out. For this example, the expected return result was 4. So let's try that out, and let's run it. Currently, we're only running the previous code for the previous problem, part 1. Let's try it for part 2. So safe equals 0. I'm going to just copy this here, actually this too, and move it down. And now we'll call this check violate here, and same thing here. And this is with violations or tolerations. Hopefully we get a 4. Let's check that out. Oh, these do not return. These don't return more than one value, they just return true or false. Okay. Okay, great. So it looks like it works. So that's the problem. And it was not too bad. Not too bad. As I mentioned earlier, every single participant in this event has their own input data. So this 601 may be the answer for me. It most likely will not be the answer for you. And the same thing for this example here, where my expected result was 559. Yours most likely will be different. Okay, if you enjoyed the content, either like or subscribe. Have a great day.